So, what is so crucial that the oxygenation of the tissues is fine? It's the function of the cardiovascular system and of the pulmonary system. And they have to be fine to deliver the right amount of oxygen to the cells, actually. Okay? And hypoxia, we got 4 types, as I said. And we're going to make a table over here. And we're going to do the different scenarios. Okay? So, I'll make a table like this. And let's put the hypoxia type over here. And I'm gonna, let's say, make it over here. I'm gonna put bigger space over here. Now we can make it smaller. So 2, 3. Okay. And what I'm gonna put here is 1, 2, 4. Okay. So, and we're going to go through different types. So, one is hypoxic. Okay. So, hypoxia. The other one is anemic. Another one is ischemic. And the last one is histotoxic. So these are, histotoxic is a special type. Okay, it's a special type of hypoxia. So over here you more think of cells and mitochondria. Okay, and hypoxia. And before we do like causes in detail, maybe, we're going to put it here. Then over here is going to be partial pressure of arterial oxygen. Okay, then partial pressure of venous oxygen, okay, in veins. Then there's going to be AV difference, arterial venous difference, okay, the partial pressures. And then there's going to be cyanosis, which we're going to do at the end. Cyanosis, okay. And what we put under hypoxia, what does it mean? Hypoxia means that the decreased oxygen in the blood is due to, or decreased oxygen in the tissue is because there is a decreased partial pressure of oxygen that comes from the lungs. Okay, so already the arterial blood has a decreased partial pressure of oxygen, and there are many causes. Okay, and as we talked, first of all, think of decreased partial pressure of oxygen in the air. Okay. So anytime you're going to go high up in mountains over 4,005 and 6, you're going to have hypoxia. Okay. Every time you're in a place where there's decreased partial pressure of oxygen, because maybe there are too many people and everyone is exhaling CO2 and no air is coming up, you're going to have hypoxia. Or anytime there's something with control of respiration or ventilation, like the opiates, you're going to have hypoxia. Or anytime there's something with diffusion, you're going to have hypoxia. Okay? So all the obstructive and restrictive diseases, yeah? Everything which, if there is something with lungs, you're going to have hypoxia. Okay? Depends. And also the shunts. Don't forget the shunts. Right to left shunts. So this would be like, I'm going to put decreased partial pressure of O2 in air. And by the way, a very important question, what is the normal partial pressure of oxygen at our level, at the sea level? How much is it in torrs, in millimeters of mercury? How much is that, if you remember?
So it's like 20% of 760?
Yes, very good. So it's about what? It's about 160 torrs or 158 torrs, yeah? And if we go up in the mountains, yeah, this 158, it won't change. Is that right? It's the same all the time, yeah?
No, it goes
Very good.
down.
Yeah, that's very important. Remember, the percents will stay the same, 21%. But the 760 decreases, okay? The total atmospheric pressure, it goes down. So that's why the absolute numbers will decrease. But the percentage will stay the same. But it changes when. So at the level of the sea, let's say it's 158 torrs. So the air that I'm inhaling has 160 torrs about. But how come in blood there's only 100? And the reason is, as you inhale, you change the percentage. It goes down. It's not staying 21 because you're mixing air from outside with the air that is in the lungs. So that's why the percentage decreases, because there's lots of CO2 in the lungs, of course. And normally in the air, it's very low. It's almost nothing of CO2 in the air you're breathing compared to 21% of oxygen, okay? But in the lungs, there's a lot of it. Yeah, remember that the venous partial pressure of oxygen and CO2 of oxygen is 40, and of CO2 is 46 torrs. So in the blood that comes to the lungs, there's 46 torrs of CO2. And not only this, but don't forget water vapor. There's lots of water. The air in the lungs is very humid, and that's why these two guys mainly, they take the percentage of the oxygen. So the alveolar oxygen is 100. It goes down from 158 to 100 about. And then after the diffusion, it goes to like 95 or 99, 98. It depends, okay? But you can say 100. You can remember number 100. That is the partial pressure of oxygen in the arteries, okay? So partial pressure of oxygen, to be like, to make it clear. So PaO2 in arteries is 100. You can remember, you can say this, millimeters of mercury or torrs. PaCO2 in arterial blood should be 40. And then if you measure it in veins, then of course the O2 is going to decrease. PvO2 is going to decrease after the blood goes through the tissue. O2 decreases to 40. And CO2, in contrast, increases to 46. Okay? Yeah? We know that this could be a bit decreased, typically. It's not ideal, but sort of. Remember 100, it's okay. And you understand that in alveolus, it has to be a bit higher, 102, 103. Okay? Yep. Anyway, so because you're mixing the air in the lungs, that's why the O2 decreases. The partial pressure of O2 decreases, okay? So we talked about like absolutely decreased amounts of partial pressure of oxygen. So it won't be 158, but if it's going to be 130 in the air, you're going to have problems. Of course, you're going to have hypoxia, okay? And then if something was with ventilation or diffusion, okay, anything with lungs will cause hypoxia. Good? Anemic hypoxia. Or we can call it, there's another synonym, and we call it transport hypoxia. Because we got anemia. In case you have anemia, your blood is not able to, in 1 liter, transfer enough of oxygen. That's why the tissues will get hypoxic, and you're having hypoxia. And either it's like really decrease of hemoglobin or functional blockage. By what? CO, carbon monoxide, okay, remember. So anything that blocks the transport of hemoglobin, it's a functional anemia, okay? So remember, anemia itself, that means decreased hemoglobin or blocked hemoglobin by CO, carbon monoxide. Good. Fine. Then you're having ischemic hypoxia. And you know this because we talked about ischemia all the time. And another cause of tissue being hypoxic, having hypoxia in them, is if the perfusion is decreased. And why? Because the blood flows slower through the tissues, and then cells have more time to take more oxygen, and they will suck more oxygen from the blood. So that's why the partial pressure of oxygen, if you measure it when it gets out of the tissue, will be much lower in veins in that specific region. Get it? Okay? So the blood that enters has normal levels of oxygen, but it enters slowly. And as the blood goes through the tissue has more time to take more oxygen, and the blood at the end is going to have decreased levels of oxygen. So that's ischemic, or you can call it, let's say, stagnative or stagnant, or whether there's a stagnation of flow. Okay? And of course, you can have a local one, because there's a partial clot or something, or compression of the artery that leads to this tissue. So there's going to be a local hypoxia, or the pump is not working. You're going to have decreased cardiac output due to MI or valve rupture or whatever you want. So either local blockage of flow, local blockage, or decreased cardiac output due to MI, whatever you want, because just the pump is not working. Okay? And then you have, as I said, histotoxic, and that's a special one. You can put cyanide, or you can put cobalt. Cobalt works in high dosage the same way as cyanide if you're poisoned by cobalt. And you know what? Lactate. If you have high levels of lactate blocks mitochondrial breathing. Okay.
Would lead be considered it?
Lead has to do more with, let's say, blood. Okay. Special types of anemia, etc. Okay. So you have hypoxic, anemic, ischemic, histotoxic. And let's go through the partial pressures. And we're going to do only partial pressures and the AV difference. And I think I will pretty clearly explain all of them, except maybe the anemic one. There's a special thing. But the other ones, you can sort of use a common sense to understand how will be the pressures. So if it's hypoxia, obviously in the name it tells you, and the partial pressure already of the arterial oxygen is decreased, isn't that right? Yeah. And these pressures are compared to normal levels. Okay. So how will be the partial pressure of oxygen in veins in case you're having hypoxia? What do you think? Compared to normal levels. If you use a common sense, well, arterial blood already has decreased levels of oxygen. The blood flows normally through the tissues, and cells want to take the normal amount of oxygen. So compared to normal levels, so let's say, as we talked over here about 40, this is going to be decreased, yeah? So it won't be 40, it's going to be 35, or it depends. But remember, the cells take the same amount, so it's going to be decreased than normal. And what is the AV difference? Will it change? That means if you take arterial pressure minus venous pressure, will it change? No. Because the AV difference talks about how much the tissues take. Okay? Yeah? So no, it's normal. Both are decreased, so it's normal. What about anemic? And over here, we're not talking about some severe anemia, okay? And this is, you have to remember this by heart. Partial pressure of oxygen in arterial blood, that is the blood that comes out of the lungs, has nothing to do with if you have anemia or not. It's just, as I said, it's only the function of the partial pressure of the air that you inhaled and how it is in the alveoli. And if the diffusion is fine and everything's fine, you really don't care about if you're anemic or not. The partial pressure of oxygen in the blood, in the artery, should be normal because it's only dissolved oxygen. Okay? So it's normal. That's obvious. But now it's getting a bit tricky because thanks to many, let's say, pH factors and DPG, and remember these in erythrocytes, in a way, although common sense would tell you that if I'm having less hemoglobin, then 1 liter like transports less, and that's why maybe at devenescence I'm gonna have less partial pressure of oxygen. No, remember, rather you should say it's gonna be normal partial pressure of oxygen in the veins. Okay, yeah, rather remember normal. It won't change too much, and that's why AV difference is gonna be normal. Okay, now you can use common sense, and again very easily with the ischemic one. And I basically told you that if it's ischemic, it means there's a decreased flow. And let's say it's a heart failure. Cardiac output is decreased. So how this will work on oxygenation in lungs? Will lungs have a problem? Basically, no. If the blood goes a bit slower through the lungs, then lungs have more time to oxygenate it. So it should be optimal. If the flow is slowed down, then in the lungs, oxygenation is like maximal, as normal. Okay. But if the blood flows slower through the tissues, then the cells have more time to take the oxygen. And that's why the venous partial pressure of oxygen is going to be decreased. Yeah. And that's why also AV difference is going to be increased. Yeah. Basically, you can remember that from the 1 liter that flew through the tissue, whatever tissue, it went slower. So the cells took more of the oxygen. That's why the AV difference is increased. And what about histotoxic? Well, of course, it depends how much you're intoxicated, but if this won't still impair your ventilation, whatever, then it should be normal. And what about venous pressure? Well, the mitochondria are blocked, they're not working, the cells are not consuming oxygen, so it should be increased. It won't be 40, it will be 45, 50, 60. Okay, and that's why the AV difference is decreased. And this difference tells you that the tissues are not taking oxygen. It tells you the cells are having a big problem. Okay, and the AV difference you can use like in very general fashion. For example, if if there's something with the brain, you can measure the carotid partial pressure in carotids, and then you take the venous blood from the jugular veins, and if there is decreased AV difference, basically you know that the cells are not working because they're not taking the proper amount of oxygen. Okay, so when this brain is dying or whatever, you can use this sometime. Well, you can use this for tissues as well, like locally. Yeah, good. So thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.